Alright. Sorry, I've just been, like, super stressed today. I had too many things going on. But, okay. Hi, I was wondering if you would advise me to pick apart an AP Physics problem. For instance, a rock is dropped off a sea cliff and the sound of it striking the ocean is heard 3.4 seconds later. If the speed of blah, 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 blah. I'm just, yeah, cool. Yeah, I'll do it for you right now, dude. Here, let me start the stream off, and then, yeah. I gotta rush through questions today, so, let's try to keep the chit-chat minimal today. Because I gotta go. I have a hard stop in an hour. I have to go. I was almost not gonna do the tutoring session today, but I decided I'm not gonna bail you guys. But yeah. Dude, come on. There you go. Okay. Cool. All right. Welcome to Office Hours. My name is Dr. Gold with Actual Education. Streaming that helps you with math homework, science homework, all sorts of fun stuff. We got a cool question here today. Kay and Nita turning. Kay, do you want to come up to the stage and talk? Do you want to talk on the stage? You can if you want. Or you can just chat down here. Whatever thing you want, dude. You let me know. Let's see where he is. Was I late? Gaming! Noise says gaming. Wait, where did Kay go? I just had Kay. Kay, come back. I just had you. Gaming. Was you late? No, I was late. That's how that worked. Yeah, I was late. What's wrong, bro?
I think he just left Discord.
God damn it. It's my hardest thing, like, when people, you know, first join Discord, I want to try to get them in as quick as I can so that they can see that this actually works and it's not just a scam. You guys know I'll help you, but, like, new people don't know that. So, that's why I try to help them out as quick as I can. Well, whatever. Yeah, what's up, Ethan?
Okay, we'll keep the chit-chat to a minimum. I want you to ask pretty question first.
Okay, cool. Alright. What is he saying? Oh, no. Okay. I will run through this question anyways. And then I'll send the VOD to Kay in case Kay comes back. But yes, Jamarcus, you probably know how to do this one, right?
So
okay.
Who can help? Who will actually help solve this?
Yeah, you want to help solve this? Here, Ethan, let's make this your. Have you asked a question in the screenshots, or this is a good physics question? You could do this one. You want to do this one?
I mean, I also have my own physics question, which I desperately need help with.
Okay, cool. Then here, I'll just run through this one, and then I'll help you with yours, because I want to make sure I have time for everybody's questions. Okay. This one says a rock is dropped from a sea cliff. Blah 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 blah. How high is the cliff? Yeah, it's not. It's someone. Someone says it's 100 feet tall. That's close, Falconer, but you have to account for the time for it to fall. Easy questions for you in the help screenshots. Oh, I appreciate that. Thank you, dude. Okay, so here's what happens. Okay. So, we have... This is like the cliff. And this is located... So, X distance tall, right? And what we know is that we have a rock, right? Which is thrown downwards, right? And that's going to take some amount of time, T1. And then, the sound of it hitting... What is it? This is the water, right? The sound of it hitting the water, this, is going to propagate upwards. And that's going to be equal to T2. And the total time from when I drop the rock and from when I hear it come back to me, that's got to be 3.4 seconds. So what I'm going to say is that T1 plus T2 is equal to 3.4 seconds, okay? You're right, Falcon, about the 100 feet. It's very easy to figure out the amount for T2, right? Because we know that the speed of sound here is equal to 340 meters per second. I think it's technically 343, but it depends on the temperature. So 340 meters per second. And there's no acceleration with sound. Sound travels at a constant speed. So if I know the velocity, right? And let's say I know the distance. Let's just say I know the distance to be x. Like, I don't actually know what x is yet, but we're going to leave it in terms of variables. Then this amount of time, if you remember, right? distance divided by velocity is equal to time. The other way you guys probably see this written is that time velocity times time equals distance, right? You guys probably see this. Distance equals velocity times time. But I want to rewrite. I want to rearrange for time. So I'm going to put that over here. Then T2 is equal to this distance divided by 340. Okay, cool. All right. We already know T2. That's great. All right, so now let's find T1. So this is where I'm going to have to use the kinematics equation, right? That I know that, what is it? X is equal to x naught plus v naught t plus 1/2 at squared, right? The final distance that it falls is technically, well, so here we can move this over. Let's say this is x minus x. Well, x naught I know is 0, right? Because that's what, well, no, sorry. I'm getting mixed up. X is 0, because this thing falls to a height of 0. And it starts, the x naught that it starts at is just x. That's the height. We're just dropping it, which means there's no initial velocity. That goes away. And then acceleration for anything that's just being dropped, that's just equal to negative 9.8. So I get that 0 is equal to x minus 4.9 t squared. Move this over. And then divide. So I get t squared is equal to x over 4.9, or t is equal to the square root of x over 4.9. Okay, and that's t1. That's this time, right? Okay, cool. So now we know what t1 is, we know what t2 is, and we can use this relationship. Which is going to be x over 340 plus the square root of x over 4.9 is equal to 3.4. And now this kind of sucks algebraically to solve this thing. Because it's a quadratic is what it is. If you're allowed to use a calculator, you could do this. The other way to do this is to, let me think. Okay. I have to say, let b equal to the square root of x. So b squared is equal to just x. And now I can resubstitute in here. So I'm going to say this is b squared over 340 plus b over 4.9 minus 3.4 is equal to 0. Now this is a nice quadratic where, you know, you do, in this case, 1 over 340 is equal to a. 1 over 4.9 is equal to b. Negative 3.4 is equal to c. And you use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you could solve for it. I don't want to do that. But you could. If you didn't have a calculator, well, you need a calculator on your test for this one, honestly. Because you can't do that quadratic in your head. Or it would take a lot of time to do it by hand. Okay. The other way to do this is just to graph it using the calculator, which I'll show you guys how that works. You guys should get used to this by this point of view. Okay, so here we have, so b squared, which is whatever, x squared over 340 plus x divided by 4.9 minus 3.4. I'm going to trace that, and we're going to see where this thing crosses y equals 0. Apparently it's pretty far there. Okay, so we got to zoom out. We got to zoom out a little bit. Here, we're going to zoom out. There, come on. Come on, cross, girl. There we go. So now I go second calc, calculate the 0. Left bound's over here. I don't know, right bound is probably way over here. And cool, I get a solution of x is equal to 13.88. Or in that case, sorry, it's not x, it's b. B is equal to 13.88, okay? We said b squared was equal to x. Okay. So in order to get the height x, we need to now square this, right? So if I take 13.88 and I square it, I get my final height, which is equal to 192.65 meters, and you are done. Were you here yesterday? I don't think so, Shifter, because that was golden hour. I would have seen you if you were here yesterday. You're okay. Yeah, this is a cool problem. I think I did one of these the other day. Yeah, the trick here is you have to know that there are two separate times. There's a time for it to fall into the ocean. There's a time for the sound to reach back up to the top of the cliff. You know those are equal to this. Then you got to solve for each time. This one doesn't have acceleration. This one does. And then once you have an expression, now you need to use an algebra trick. You need to recognize that this is a quadratic, because I have something to the first power, something to the 1/2, which is kind of the same thing as something to the second, something to the first. I just have to re-index my variables, basically. That's what this is. It's a trick. Can you be next, please? I'm going in order, so depends what order you're in. Sensation, come up to stage. What's up, Sensation?
Hello.
How's it going, chap? Having a good time?
It's been one of those days.
Did you have Fish Fridays, dude? It's Fish Fridays, man. Fish Friday.
Fish Fridays. Not yet.
Not yet. Not yet, he says. Okay. Mushy peas. Mushy peas on Friday, right? That's what we do. Mushy peas.
Next one?
Uh,
Next one now?
Are you next in the screenshots? I don't see you in the screenshots. You're last in the screenshots. Teacup is next.
Remember you said...
Teacup is next, but I
Remember
don't... What did I say, Ethan?
You said that you would do this and then you would do mine's next. Apparently you said that.
Oh. Well, I'll do yours next. I'll do yours next in the queue. I'll do yours next in the queue is what I meant. Okay. All right. Teacup, what's up? This is a little bit. This is not a question you're doing yet. This is not yours. This is integration. We haven't even gotten into integration yet. Nope, we're not doing that.
What even was that O?
That O? Oh, that was just
like an O.
No, it was just an integral is what it was. What do you mean, this thing right here?
Yeah, I mean, what on earth is that?
That's an integral. This is technically the integral of negative. This is e to the t over square root of 9 minus e to the 2t dt.
Oh, it's E, the number E.
Oh, this! Yeah, this is an E. Yeah, E. Yeah, 2 point.
Okay, I know what that is.
So-
It's like an O. I was like, what?
I know. Yeah, it looks pretty weird. Yeah. Okay. Yeah, this is cool. This is a trig. This is a trig integral actually. But yeah, Teacup is nowhere close to this yet. Teacup is still on this, which I think was multiple derivatives. I'll pull one up from. Yo, wow! Thanks, the Gendler. My brother, my wolf brother is in the stream. What's up, dude? When are you gonna stream again, Gendler, dude? When are you gonna stream? I'd watch your streams. What am I look? Calculus? Fucking fuck. Your first investor. You are my first investor. Nightbot is wrong with the yours. That's too funny. Alright, let's see. What the fuck was this? Where were I going? Your first investor. Tov. No, he's way down here, I think. Until there were too many. What's up, Sensation?
Jamaica says, how is that trig? Confuse.
Oh, because it uses a trig identity in order to do the integral. I think it uses 1 minus secant squared is equal to tangent squared. Or wait, fuck. No. It's 1 minus cosine squared is equal to sine squared. That's what you do. Jamarcus, you basically replace e to the t as cosine of something, and then 1 minus cosine squared is sine squared, and then you have a square root of sine squared, which is just 1 over sine. Yeah.
Yep, never heard of that myself.
I know, it's okay.
Second year A level.
No, it's like the second calculus course, I guess is what it is. One sec, I'm trying to find a question for Teacup. Teacup should really be doing this himself, but it's okay. I'm being nice today. Derivatives, yes. I want multiple derivatives. Where was it? Yes. Leibniz notation? What the fuck is that?
Leibniz notation.
Leibniz notation. I think that's just putting commas. Is that just using commas instead of saying dy dx?
Do you know what? I can never remember the difference between Newtonian and Leibniz.
They were developing shit at the same time, weren't they? Leibniz and Newton?
Yeah, and then they were accusing each other of stealing each other's work.
Really? Dude, what? They're like, yo, bro, you torrented my math textbook. How dare you? It is actually kind of it's a crazy cool phenomenon that actually in the world, like certain scientific developments have happened at the same time in completely different countries with people who had no clue about each other, like were never in contact. Like for whatever reason, certain big advancements got made at the same point in time, which makes you start to believe like, oh, is there like some general plot line that humanity's supposed to go through, and like we just hit like that checkpoint, like that save point?
The Akashic Records.
Srinivasa Ramanujan? Who's that? That sounds like a math guy.
Sounds familiar.
Yeah. Indians were actually pretty dope with math. Actually, the Arabs were really good with math too, actually. There's a lot of really cool stuff they did with that. Indian dude that figured out a bunch of high-level stuff on his stove. That's cool. That's cool, Gendler. I didn't know that. Yeah, that's what he's talking about. Okay. Yeah, exactly. Wait, shifting and scaling rule? Bro, like what? Oh my god, Teacup. Why am I taking so long to find you a question? No, I don't want implicit. Dude, what? It's killing me. Trig functions, no. There we go. Here we go. Here we go. This is it. This is it. Oh my fucking god. Alright, here we go. Alright. I don't want that one. Yes, I want this. I'm gonna do this one for Teacup. We're gonna do this one. This is a good one. Da 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 da. All right, Teacup, what's up? You here? Where's Teacup? Come to the stage. I'm moving and grooving. If not, I'm moving on to other people. India made 0? Really? Is that true? India made the number 0? That's cool. What's up, Justin?
I've heard that.
India created the concept of 0?
Y'all, what's good?
Yeah, what's up?
I'm at somewhere, so it's gonna be like really busy.
Okay. Well, you just mute your mic if there's a bunch of noise. Yeah, pretty sure. Cool. Okay. All right. Teacup's not here. I'm gonna go to the next person. That is you, Nick. Come on up, dude. Where you at? Do you need permissions to come up? Sorry. Probably do need to give you permissions. Come on up, Dark. 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 Where is he? Are you on Discord, Nick? Yes. What's up, Nick? Come on up. Yeah, there we go.
Hello there.
What's up, dude? Okay. Wait, dude, where did I just put your question? Okay, so let me see. You're doing something, not my question, but I would just know how to solve this. Okay, so you have like two questions.
The one on top of it, that's my homework, and the one under, I just saw my friend doing it. I was like, yo, what the hell?
Okay, no, that's cool. That's totally cool, dude. We can do it. This is actually a very good one, honestly. I like both of these questions. 12 years in the Twitch. I think that's the biggest we've had in a hot minute. We've been averaging like 7 or 8. I'll take 12. People enjoying the Friday. I'm going to a concert in like an hour. What? We should what? The TV what?
I really wish I'd kept my Justin.tv login, but I lost that a long time ago.
What's Justin.tv?
Justin TV was Twitch before it was Twitch.
Oh, no way. I didn't know that. That's cool. There's a history to it.
Justin.tv, and then Twitch formed around it, and then Amazon bought Twitch.
Oh. Yeah, I mean, yeah, I know they have all the Amazon Prime stuff that we get. Apparently Call of Duty has a beta this weekend, too. I'm not going to have any time to play it, but that would be pretty cool. Justin TV was Twitch. Oh, that's cool.
1/3 as an exponent.
Yeah, I'll show you how that works. That's cool. All right, let's do this. So they're saying the square root of 100 times the square root of negative 40. And what, they just want to know what the answer is?
Yeah.
Okay.
My question is that while we were in class, she showed negative 19, and she said that there was no answer for it, so she left it as negative 19.
Yeah, I mean, the reason for that is 19 is prime. So what this comes down to, Nick, this comes down to reducing radicals and whatnot. Do you remember, for instance, how to reduce, like, radical 8, for instance? Do you know what that reduces to?
Nope.
Okay. You got to write out the factors of 8, all right? So what are the factors of 8? What things multiply to 8?
2 and 4.
Good, 2 and 4. Okay. Nothing really multiplies to 2, right? Because it's like 1 and 2. That doesn't really do you any good. What multiplies to 2? To 4, sorry.
2 and 2.
Yeah, good. Okay. So now you're done, because now you have all what we call prime numbers. These are prime numbers because they can't be factored out any further, right? Okay. So anytime you see a pair of numbers, you can then take that pair and you can pull it out. And so I'm going to take this, I can pull it out, and then whatever's left is left inside the radical. So this becomes 2 root 2.
Oh, okay.
Yeah, do you see that?
Yeah,
Cool.
I forgot how to do this, and I didn't know how to answer the question. Yeah.
It's okay. So, all right. So, okay, first of all, they have negatives inside radicals. Anytime you have a negative inside a radical, you could just pull that out as an I, is what you can do. So just get rid of this and call this I. Right? I didn't skip Teacup. I asked for you, but you didn't come up to the stage. I did not skip your question. I did do your question, but you weren't here. Oh, bro, it's not my job to ping you. You need to be on the stream. Yeah, I'm sorry. Sorry, I'm in a mood right now. I'm not you guys' fucking babysitter.
Brother, I need some coffee.
Yeah. Okay. So anytime you have a negative, you pull an I out, right? Okay. I didn't ping aspect. Well, I did ping aspect eventually. Yeah. Well, okay, whatever. You should know better. Okay. All right. So now once I have this out, right? I have I square root of 100, right? And then I 40, right? Okay. Let me think how this is going to work, actually.
Noise did answer it in, what was it? Vectors are the thread.
Now I'm curious, because if I do this by pulling the I out, I'm going to get a negative number. But if I were, for instance, to do like negative 10 times, negative 20, this is the same thing as the square root of 200, which this will be a positive number. But but yeah, wait, I'm curious actually here. Wait.
Because he just pulled out 10 and 20, and
Yeah, because I don't think this is right. One sec. Let me check this. Sorry. Now you got to get a new question? No, actually, Teacup. No, Teacup, this is double folded. I spent like 5 minutes trying to find you a question because the question you asked wasn't good. All right, one sec. One sec. I want to see if this works. Times the square root of... I'm missing some like core concept here real quick. Oh, it is negative. Interesting. Okay, cool. All right, good to know. All right, cool. Yeah, so, okay, we're here, right? So anytime you see a negative, pull an I out, okay? All right. Now what you need to do is then reduce these things, okay? So how can I reduce... What's the square root of 100?
10.
10. Good. So that's 10I, right? Times I. Times the square root of 40, okay? The other thing you learn is what's I times I?
-1.
Good. That's -1. Good. So this is -1. Okay. And then now we need to reduce 40, okay? So this is where you need to use the same reduction rules we did earlier, right? So what are some factors of 40?
10 and 4.
Good. So let's do 4, 10, okay. What else can I do?
2 and 5.
2.
No, 2.
No, 2 and 5. This is 2 and 5. What about this one?
2 and 2.
2 and 2. Okay. Okay. Now I need to look through my factors here and see which ones are pairs, right? Where do I have a pair here?
2 and 2.
Well, just 2 of them, right? Just 2 of them. So these 2 are going to come out as a single 2. Okay? A single 2, all right? And then whatever's left has to stay inside the house. Okay? So this is going to become 10 times -1 times 2, and then what's left inside the house?
2 and a 5.
2 and a 5.
Just
Good to see you again, Lair. Appreciate you, dude. Thanks for the sub. I love you, dude. Enjoy your Friday. I'll chat to you later tonight because I'm gonna be out at a concert. Yeah, you have the 2 and the 5, and then what do I do with the 2 and the 5? Do I just write 2 and 5 here? Nick, you multiply them. Good. So instead of just writing 2, 5, this is gonna be 10. Okay. So then your final answer, right, is going to be -20 square root of 10. You see how I multiply these all together? And that's what I get? Good. Nice. Okay, I'll show you the cubed root one real quick, if you want. This one? Because it's the same concept, is what it is. Okay. Anytime you see something to the 1/3 power, okay, that's the same thing as saying the cubed root of 512, okay?
Oh, damn.
So, for instance, if this was to the 1/2 instead, this would be the square root.
1/2 as well.
Yeah, that's square root. We just don't write the 2 here because we're lazy.
yeah.
Okay? All right. So this is the cubed root of -512, okay? Don't worry about the negative for now. Don't worry about the negative, okay? Let's just like leave it out here for now. We're going to do the same thing where I'm going to break this down into factors, okay? So I need to start breaking this down. So what do you know are factors of 512? You should know this from computers. You should know this from computers. Like, if you buy like I don't know, flash drives, hard drives, whatever, what are the numbers that you usually see?
16.
Okay, what's another one you see?
32.
What about, yeah, keep going.
128.
Good. What else? What's higher than 128?
I think 280?
256.
Oh.
Yeah. So are you seeing like 64, 128, 256, and then the other one is 512 is what it is. Okay.
Oh. Okay.
Yeah. Okay. What these all are, these are all multiplying by 2, is what they're doing. And the reason for this is because in computers everything works in binary, which is 1s and 0s. It's a bunch of like 1 0 1 0 1 1. So and everything has like 2 different values it can have. So that's why everything in computers tends to be factors of 2. Okay. The key thing I want you to see here is that 512, right? That is 2 times 256. Okay. So here's what we're going to write. We're going to write 2, 256. Okay. And then how can I break 256 down?
By another 2.
Yeah, and what does that break down to?
128.
Good. What does 128 break down into?
64.
Good. Keep going.
Here you can do 8 by 8, right?
You could do 8 by 8, but here's the key thing. And that's fine. We can do that. The issue is that I need to find, when it's the cubed root, I need to not only find pairs, I need to find triplets, is what I need to do. Okay? That a cubed root means I need to find triplets. A fourth root means I need to find 4 things, yeah. So, I would do this as 232. Again, there are faster ways to do this, but I just want to like kind of show you how it works. And then 2, and then... Okay, well, here's... Okay, I will show you one faster way how it could work, I guess. Okay. 64 is the same thing as 4 and 16. Okay? And then 16 is 4 and 4. Now, here's the cool thing. Do you see how I picked out a triplet here? So now I don't need to break these down anymore. Because if I can eliminate all these things as a triplet, I don't need to break them down anymore. I can just leave them like that. Because technically, I should also break this down, and then I should break this down. But the exception to this rule is that if you can already find the grouping that you're looking for, so in cube roots you're looking for triplets, you can just pull it out right away. So I see I have a triplet of 4s, and I have a triplet of 2s. Okay?
Mhm.
So now I'm going to pull each one of those things out. Okay?
Mhm.
And now there's nothing left, right? This is the cool thing. This is a perfect root, right? So this is going to be 2 times 4, right? Which is just equal to 8. What happened to the old... No, I have the old headset. I did my hair for tonight, and I don't want to put a headset on. It's going to ruin my hair. So I have earbuds. Yeah, so then this is just 8, okay? Now there's a key thing here, though, because we still had the negative. So... And this has to do with even and odds. So if the power you're doing is odd and it's negative, this is going to be a negative number. If the power you're doing is even and there's a negative number, then you're going to pull out an I. Okay?
Oh, that's why it becomes I, because it's on the 2.
Yeah. So this is just going to be equal to, this one just equals negative 8. Okay? Because it has a negative. Whereas before on this one, right, because these were square roots, right, if you have the square root of negative 100, you're going to have to pull out an I, and then it's times 10.
Mm-hmm.
Okay? That's how that works.
Cool.
Cool? Does that make more sense?
Mm-hmm.
Dope.
Yeah.
You're welcome.
Watch the video in the chat. It's so cool.
Quantum locking, that's cool. When I have time, yeah, I'll watch it. Okay, cool. All right. Teacup, you here? Am I gonna ping you, Teacup? I'll ping you, dude.
Oh, I forgot. If you didn't know you can do 4, 4, and 4, then you continue doing 2s.
Oh, from the
Yeah,
beginning?
a lot of 2s. What would you do with them?
What do you mean?
Now, yeah,
I'm gonna ping you. I'm gonna ping you again, dude. Wait, one sec. What's up, Nick? What are you talking about?
Like you took out 4, 4, and 4.
Oh yeah. No,
What if
you
continue?
no. You know, once you take them out, you can't break them down anymore. So once they're taken out, you can't break them down. Like you're done.
No, I'm saying before you took them out. I'm saying while you're distributing them still.
Yeah, I could have done this, right? But you see how I'd have a triplet of 2s and a triplet of 2s? So that would be 2 times 2, which is the same thing as 4. It's the same thing as pulling out a whole 4. Yeah, that's why that works.
Okay, thanks.
You're welcome. Okay, Teacup, let's try to do this. Find Y double prime. Wow, what fun. Do you know how to do this one, Teacup? Teacup. Teacup.
1, 2, 3, 5, 4, 3, 2, 1, 7, 8, 1, 9.
Sorry, what, dog?
Okay, well that means it works. Hello.
What's up? Hello. Yeah. Do you know how to do this one?
Okay, so we're taking derivative twice.
Yes. How do I take the first derivative? There's actually there's an easy way and a hard way to take the derivative first here. Ah, yes. Falcon has the idea. You could foil it, but foiling sucks.
I would rather die than use foil.
Yeah. Well, I can. Well, yeah. So yes, Falcon, you are correct. I could foil this first, right? Which would be, I don't know, this stuff, whatever. This would become x to the 5th plus x squared plus x to the 4th plus x. Right? I think that's how it works. X to the 5th. X to the 5th, x squared, x 4th plus x. Right. Yes. And then you could take derivatives of everything, right? So then this would be 5x to the 4th plus 2x plus 4x to the 3rd plus 1. That is correct. You could do that. The only issue is that, like, sometimes this gets messy, right? So let's say, for instance, I had, like, x plus 2 squared. You're right that I could just multiply that out with FOIL and then take the derivative. But where this gets a little tricky is that, let's say I had this to, like, the 6th power. I really don't want to FOIL x plus 2 times x plus 2 times x plus 2 times, you know, like just kill me. That would really suck. Yeah. This is where the chain rule comes in a lot of handy. Yeah. Yeah. Okay, but let's see. This one you can do using the product rule, which I think is cool.
Hell,
So-
product.
Yeah, let's call this thing A. And then let's call this thing B. And what happens when I'm trying to take the derivative of A times B? What does that become?
A
Do we-
times B or A over B?
A times B. I'm trying to take the derivative of two things multiplied by each other. What's that?
Is that just A B prime?
That's A prime B plus B prime A. So the other way is right like this.
Oh yeah, it makes sense.
So you take the derivative of the first one, multiply by the second, take the derivative of the second one, multiply by the first. Yeah. Okay. This is actually probably harder, honestly. Than yeah, Falcon, you're right. Foiling it is actually the easier way, but like let's try it this way.
I'd rather die.
Okay. How do we do this? What's a chain
Okay,
rule? We've done the chain rule before. I can do it again at some point. That's all right. Yeah. Let's go.
So are we gonna put in? Are we substituting now, or are we just doing it again?
Well, let's do the derivatives, right? So what's A prime? If this is A.
A prime would be. Let's see, it would be 2x to the first plus x to the 0, which is just 1.
2x plus 1. Yeah, it should just be 2x plus 1, right?
And then b would be.
X cubed plus 1. It's the same thing, right? This means
Well,
don't take the
yeah.
derivative of it, right?
And then a is x squared plus x, and b prime is 3x to the second plus 0.
Plus
1.
0.
I don't
Yeah, good. Yeah, it's just like that. Yeah. So this is cool. This is an example of how the product rule works, but as you can see, this is now more of a mess to deal with. So, because then if I had to take another derivative, right, now I would have two chain rules. Because now I have A, B.
We got a,
I'd have two different product rules I'd have to do.
we got a, b, and c, d.
Yeah. Yeah, Jamarcus, you're right. This is much harder than foiling. But okay, it's cool to see it. All right. Yeah, okay. So this is yeah, it's okay. This one's easy. This is just x to the 5th plus x squared plus x to the 4th plus x, right?
Man, I hate foiling.
I know. But I mean, if you don't like foiling, you can do my way of doing things, which I like to do this. So I just do x
Nah, I
squared
want that.
x. You don't like this way? I think this way is cool.
Well, I can't remember how to do
And then you
it.
do this. So x cubed times x, that's x to the 5th, right? X squared times 1, it's just x squared. X cubed times x is just x to the 4th. And then 1 times x is just x. And then you get the same thing. You get the same thing.
And then
Okay.
what do I do? Take the derivative of all of that.
Yeah, take the.
twice.
You know how to take the derivative of this, yeah. So what's the derivative of this?
So we got 5x to the 4th plus 3x to the 3rd
4x to the 3rd.
plus 4x to the 3rd, and then 2x to the 1st, and then we just got 1.
Yeah. Yeah, Falcon's like, I've never seen that. Yeah. I find it a lot easier, especially when you start having like this, like x squared plus 2x plus 5, like times x to the 3rd plus 6. If you start having bigger things and whatnot, this becomes a real pain to remember like all these things. So I would much rather do it my way, which is it's the same Punnett square thing you use in biology, right? Where I would just do this, and then now I just do this. It's the same process, but this to me is like visually easier to like keep up with. Yeah.
Do the derivative again.
Yeah, do the derivative one more time. What's that?
So we got 20x to the 3rd plus 12x to the 2nd plus 2x to the 0.
Well, which is just 2, right? X to the 0 is just 1.
Yeah. And then plus 1 to the 0 is just 0.
Just 0. And it's not 1 to the 0. It's plus 0 times 1. So this is just times 0. So yeah, this goes away. Cool. Yeah, good. There you go. You did a good job.
That's dope.
Okay, cool. Ethan, let's do yours.
Alright, I'm here. I'm here.
Okay, cool. Let's do it. All right, good. I got like 10 minutes. Hopefully I can get through yours and then get to Jamarcus. So let's see. Okay. All right, a granite rock has
Let me see how-
a mass of 15.5 grams and a volume of, is that 6.01? Does that say 6.01?
Yes. Yes, it is.
Okay, cool. So mass is equal to 15.5 grams. Volume is equal to 6.01. They say this is cubic centimeters. What is the density? Oh, I like this. Okay. So now they want to know the density in grams per centimeters cubed. Okay, that's kind of cool. Do you know the equation
What
for
about
density?
kg?
Yeah, we'll do the other one next. Here, let's do the first one.
All right, hold on. For density, is mass over volume.
Good. So, yeah, we say D is equal to M over V. I fucking hate the DMV, but yes, D equals M over V. So,
Actually, speaking of something,
yeah.
they actually gave us another thing. It's like a triangle with these three. things.
Yeah, I know they do this or something. Like, I don't know. Yeah, it's cute. Whatever. Just do this. You don't need to know any more pictures and stuff. You know how to rearrange things, right? You know if I'm solving for V, right? I multiply both sides by V and then I divide by D.
Okay, geez, that's not how we do it.
I know. You have some cute little triangle. I know, which is I don't it's something like this, but I see the fact
it's
that
not that. It's not. It's
the fact
not,
that I even forget how it works, like, yeah, that's why it's kind of like useless.
man.
Okay, here we go. D equals M over V. So you have the mass, right? That's 15.5 grams, and you have the volume, right? That's 6.01 centimeters cubed. Okay. So then all you have to do, right, is just plug this into a calculator. This is just 15.5 divided by 6.01, right? So that's 2.58. And then here's the cool thing. You already have the units here, right? You see how this is grams per centimeters cubed?
Yes.
Good. So now that part's done because you have it in grams per centimeters cubed, okay? This is where this gets tricky, though, because now they're asking for kilograms per meters cubed, right?
Yeah.
Okay. This is where we want to use what's called stoichiometry to do this. So I want to know, question mark, how many kilograms per meters cubed is equal to 2.58 grams per centimeters cubed? Okay?
Uh-huh.
All right. So let's try to convert some things first, okay? Let's try to convert. So what we're going to do is we're going to multiply these things by like factors and stuff to try and simplify it out. What do I know? So I need to get to kilograms, right? But I'm starting with grams. What do you know about grams and kilograms?
1,000 kilograms is equal to a gram.
Nope. If 1,000 kilograms is equal to a gram, every cocaine dealer in the world would be fucking rich as fuck. It's not. It's 1,000 grams is a kilogram. People always get this wrong.
I got that mixed up.
Think about it. Which one's heavier? Is a kilogram heavier or a gram?
A kilogram is like a part of the gram, so I guess the gram is heavier.
No. Kilogram is bigger than a gram.
Oh.
Yeah, kilograms is bigger. Like kilos. Kilo.
Right.
Kilo is 1,000.
Because-
Right? Remember 1,000
Yes.
grams. Yeah. Okay. It's okay. Everyone always gets that wrong. I don't know why everyone always gets that wrong. Okay. So I know that 1,000 grams is equal to 1 kilogram. How am I going to represent that as a fraction right here? How am I going to do that?
Is it gonna be like 1 kg over 1,000 g?
Good. I had 125 milligrams of caffeine yesterday morning. That's pretty standard. That's like two. It's like that's like 2 cups of coffee, I think. Yeah, and then the reason we do that in this way, right, is because I want grams to cancel with grams, and then that'll just leave kilograms, right?
Yes.
Okay, so now this gets confusing though. This is the confusing part. I need to go from centimeters cubed to meters cubed. Okay. What do I know about centimeters and meters?
It's something like, how do you say it? Is it like 0.02 centimeters is equal to a meter or something?
No. No.
Because
You have it
I know
backwards
it's
again.
like I know it's again.
You got it backwards again. Yeah.
Centimeters is like 10 to the negative 2.
Yes, good. So we say that 10 to the minus 2 meters is equal to 1 centimeter. 10 to the negative 2 is the unit on the first thing. It's on the regular thing without any of the prefixes or the suffixes. Just in the same way, like kilogram is 10 to the 3, right? That's why 10 to the 3 meters is 1 kilometer. Okay? Whatever this exponent is, they're talking about the regular unit, and then it's equal to, like, the special unit. One of the special unit. Like, do you know what milli is? What's, like, millimeters? What's that?
10 to the negative 3.
Good. So how would I write that?
10 to the negative 3 meters is equal to 1 millimeter.
Yes, dude. Exactly. Does that make sense? That's how you do it. Okay, cool. All right, awesome.
Yes.
Good. Okay, cool. All right, so we have this. So how am I going to represent that down here?
Meters and centimeters. I think you do 1 cent. No, wait, hold on. 10 to the negative 2 meters over 1 centimeters.
Well, I don't want meters on the top, right? I want meters on the bottom.
Now, why would you want that on the bottom? You wanted to go even higher?
Well, we want meters on the bottom, right? So I want to make sure there's a meter thing here on the bottom, right?
Alright, so it's just 1 cm over 10 to the negative 2 m.
Good. Now, here's the key thing. Do you see how this is centimeters cubed?
Yeah.
And this is only centimeters. So far, this is only going to kill off one of these things, which would make it a 2. Okay? So what I end up needing to do here, Ethan, is I have to do this thing 3 times. I'll show you why.
Dang.
Yeah, this is the trick. Because watch here. Ethan, do you see how centimeters times centimeters times centimeters, that gets you centimeters cubed?
Yeah, I know that.
Which will kill this off. And then this is meters times meters times meters. That gets you meters cubed, which is what you want.
Alright.
Okay, good. Okay, so now you're done, right? So this goes away. 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 And this goes away. And you're left with kilograms over meters cubed. So the last thing we got to do here, right, is we got to do the math. So I got to multiply everything over here on the top. So that's 2.58 times 1 times 1 times 1 times 1. That's just 2.58, right?
Yeah.
And then this might be a little hard. Do you see how we have 1,000 and then 10 to the minus 2, 10 to the minus 2, 10 to the minus 2? You should be able to do this in your head. I want to show you how you can do this in your head, all right? 1,000, that's the same thing as what? 10 to the what is 1,000?
10 to the 3rd.
Good. So this is 10 to the 3rd times 10 to the minus 2 times 10 to the minus 2 times 10 to the minus 2. That equals 10 to the what? What happens when I combine all of these?
10 to the negative 3.
So this is 3. Yeah, good. You're right. Yeah, 3 minus 6, right? Which is negative 3. Perfect, Ethan. Good. So then this is 2.58 over 10 to the minus 3. And if you have a negative exponent, you can just put that on the top. So this is the same thing as 2.58 times 10 to the positive 3.
Alright.
And this is already in scientific notation for us, which is like super dope, right? Yeah, we love that, dude.
That's dope.
Because we already have just one number and decimals. So this is your final answer, right? This is 2.58 kilograms per meters cubed.
That's dope.
That makes sense?
Yes, it does.
Perfect, dude. Nice. Okay, awesome. All right, I will do, Jamarcus, I will do your question. And then I got to bounce. I really got to bounce. I'm sorry. I wish I could spend longer with you guys today. You can skip if you want. No, Jamarcus, I'm not skipping you. What was your question, by the way, Jamarcus? What was it? Well, let me see what your question was. I didn't ask a question because I don't really have an example I wanted to know. But here are two things I was interested in. How do you solve a system of equations with exponents in it? And how do you use the product and quotient rules in derivatives and integrals? Okay. How do you solve a system of equations with exponents in it? I actually don't know how to do that, honestly. Yeah, so you bring up a good case here, Jamarcus, right? Yeah, which is where's my thing? Where's my thing? Yeah. If I have, like, for instance, what is it, like 3x squared plus 2y is equal to 4, and then x plus y is equal to 6. I mean, hopefully you can still do substitution, right? So I could still solve this, Jamarcus, right, by saying that x is equal to 6 minus y, and then I could plug that into here, and then I could square it. So I think substitution would still work, unless it's, like, super messy. But you're right that the traditional methods of, say, for instance, doing the elimination method, or even using, right, matrices to do it, right, where we did, like, the RREF method, that's not going to work if you start having exponents. This only works for linear equations. This is why it's called linear algebra, by the way, too, right, because it's all linear equations. The second you start throwing in more stuff, this becomes, like, nonlinear, which is kind of tricky to deal with. I think substitution is your best bet, is what it is. Okay, cool. Awesome. That's a good question, Jamarcus. Yeah, I can go over the quotient rule stuff on Monday. Let's do that next time. All right. Jamarcus gets coin too. Good job, Jamarcus. Oh, Jamarcus. What was it? Titan won the Discord Nitro, and he wanted to give it to you if you wanted it. Otherwise, I'm going to give it to Falcon, so you let me know.
I've got a quick one for you.
Yeah, show it to me. What's up? Is it the one on your screen right now?
Yep. Question 25.
Got it. Let me pull it up. Got it.
If you can see it.
I can. You're good.
Meow.
Meow, meow, meow. Okay. Here we go. This is it, right?
Just my hand in
Bye,
the way.
Yeah.
Put your nails.
Okay. It says the average age of teachers at a school is 36 years. Mrs. Smith's age is 11/9 of the average. How old is Mrs. Smith? Okay, this is cool. This is kind of it's an algebra question. It is. Yeah, okay. So, this is 36, right? And then we know Mrs. Smith's age, right, which is x, is 11/9 of the average, okay? This is like the same thing if saying, like, you're 30% of the average or, like, 40% of the average, right? What you want to say is that x, right, the amount that Mrs. Smith's age is equal to 11/9 times the average, which in this case is 36. So you just want to multiply these two together. Yeah. It's I'm trying to think if there's another way to say that. Yeah, no. This is the easiest way. Like, anytime, for instance, you've seen coupons before, right? What if they say, like, you know, 30% off, I don't know, a $20 beer or something, right? How much money you're getting off?
$6.
Yeah, how did you do that? How'd you do that in your head?
10% times 3.
Good, yeah, you did 10% times 3. That's smart. That's a good way to do it in your head. Yeah. So what you did is you basically did this. You converted this into a decimal, which is 0.3. The other way to write this is the same thing as 3 over 10, right? So this is 3 over 10 of $20, right? Which then equals 60 over 10, which just then equals 6. So you're right. You just take $6 off. You're right that the smarter way, yeah, especially when you have, like, multiples of 10, it should just say this is 10%, right? And then move the decimal over 1, and then multiply by 3.
I mean, the obvious other way is 20 times 0.3, but then you use calculators.
Yeah, exactly. But then that sucks, right? Yeah, there's all sorts of cool math tricks with things. So in this case, it's the same thing, right? If I have 11/9 times 30, 11/9 of 36 is just 11/9 times 36. And then, do you know how to do this in your head mentally? You don't need a calculator for this.
11 over. Right, 36 over 9 is 4.
Good.
And And then 11 times 4.
Yeah, 44. Good. Good. Good.
Yeah.
Yeah, very good. Yeah, you do this 36 over 9, which is just 4, and then it's 11 times 4, which is equal to 44. Nice, good job, dude.
I think
Yeah.
I went off on some mad direction.
You did.
Uh,
Yeah, I see you dividing
yeah.
things and whatnot. Yeah, no. Don't overthink it. Don't overthink it.
43.92, and that was just like approximately 44.
No. Yeah, that's because you were manually doing the division. That's all good. Okay, what's up, Ethan?
I want to say two things.
All right, say 2 things. Do it.
Okay, so see, do you remember about that physics test I told you about?
Yes.
I posted the grade today.
Oh, good. What'd you get? How'd you do?
I got 80.
80. Not bad. Not bad. We should get you an A though. You should be able to get an A.
Yeah, it is. That should happen.
Okay. If you have a copy of the test, you should bring it to me so that I can help you with what you got wrong. Right?
Honestly, I see my mistakes. And
Okay.
The teacher allowed us to actually fix our mistakes.
Okay. All good. All right. And what's up? What's the other thing?
So okay, so how does the tournament actually work? How do you actually get coins for that? I'm wondering because if it's not from office hours questions, what else could there be?
There's dailies, and then there's competing in the tournaments. Teacup will go over the rules. You guys voted for Fortnite to be the first game, so it'll be a Fortnite competition, and then Teacup is going to do the scoring. So any questions about that? Talk to Teacup. Teacup's in charge. I put him in charge of it.
Alright.
Cool. All right. Thank you everyone for coming to Office Hours. Had a great time with you guys. Come by to our next stream. That's going to be on Monday at 3 p.m. Pacific, 5 p.m. Central, 6 p.m. Eastern. You got any homework questions? Like, please come by, ask them. If you found us on TikTok or whatever, Twitch, our Discord link is right there. It's in the chat. Join up, and that way you get the notifications for every time we go live and all of the other fun stuff we do. I think this weekend they're going to have a little Fortnite tournament for things, and I give out prizes to people for doing well in that. And you don't even have to do well. I think we're also giving points out to people who just participate. So any questions, ping Teacup. He's in charge of it. And yeah, I will see you guys on Monday. Have a wonderful weekend. Enjoy everything. Live life. Stay safe. Cool?
Bye.
All right. Peace out, guys.
That's dope.